Hi guys, good evening. Hello Sahaj. Hi Pranav. Hi Rahul sir. Hello Jia. Hi Farhan, Divya. Hi Harshal. I'm sure I'm audible and visible to you guys. Hi Veda. Please let me know in the chat box in case I am audible and visible. Hi Jia, Virendra. Good evening Rahul sir. Happy Raksha Bandhan to all of you guys. Happy Raksha Bandhan to all of you. How was your day? How many of you celebrated Raksha Bandhan? Tied Rakhi. I'm good, Shahini. How are you? Happy Raksha Bandhan to all of you. I did ठीक ठाक था. Okay. So attendance I can see is less today. It is because of Raksha Bandhan only. Hello miss, I have a doubt from class 11th chemical bonding chapter. How do we arrange molecules based on dipole moment? Arrange in which? In the increasing order of dipole moment. It depends on the electronegativity. Like you can give me the question and I'll solve that. I'll go after this class. Acha. What is the time there right now? Right here it is 9:20. आज आपकी ही अकेले क्लास है. Our math and physics class was cancelled, so today we have only chemistry class. Okay. 7:45, 6:50. Okay. But celebrations are done in the morning, no? Celebrations are done in the morning. Yes. Why you are celebrating in the evening? 7:48 there. Okay. All right. In UAE, right? हमारे भी बॉटनी की क्लास कैंसिल हो गई आज. अच्छा, ओके. अरेंज द फॉलोइंग in the increasing order of the dipole moment. What molecules they are? Wait, let me write them down. We have HBr, HBr. Then we have H2S, NF3, H2S, NF3. And then we have, अरे यार चैट ही नहीं दिख रही. Wait, chat. अरे यार messages कहाँ चले गए? NF3, CHCl3. Okay, CHCl3. So we have to arrange them in the increasing order of the dipole moment. Dipole moment totally depends on the shape as well. If I'll talk about CHCl3, it has tetrahedral shape, right? CHCl3. Chlorine here, and chlorine here. This is NF3, wherein the shape is pyramidal. Nitrogen has lone pair. H2S shape is bent. H2S है ना? H2S, wherein it has two lone pairs. And in case of HBr, dipole moment comes because of difference in electronegativity. Good evening, happy Raksha Bandhan, Mahi. So, in case of CHCl3, between carbon and chlorine, there is electronegativity difference. Dipole moment is in this direction, dipole moment is in this direction. Here, dipole moment is in this direction. Here, it is, this bond is almost non-polar. So, the resultant of these two will be in this direction, resultant of these two will be, but they won't be cancelling each other. There is no cancellation here. If I'll talk about NF3, in case of NF3, the shape is trigonal pyramidal. Dipole moment is in this direction, dipole moment is in this direction, and this is in this direction, but lone pair is in upward direction, right? If I'll talk about H2S, sulfur is more electronegative, dipole moment here, and because of a lone pair also there is a dipole moment. In case of HBr, there is just one. Br is not that much electronegative. This has delta negative and this has delta positive. So out of all of them, you can see if I'll talk about H2S and NF3, lone pair is in upward direction. This the three NF bonds dipole moment that is in downward direction, and in case of H2S, Lone pair is in upward direction, resultant is also in an upward direction. So H2S would be having higher dipole moment as compared to NF3. So no cancellation is taking place over here. So H2S would be having the maximum dipole moment, H2S. After that, we have this NF3. Now let's talk about CHCl3. In case of CHCl3, resultant is in this direction, but this one is in opposite direction. So somewhat cancellation will also take place over here, and there is no lone pair. Then we have CHCl3. After that, we have the next one, which is HBr, the least one, as it has only one bond, which is polar. Okay. Divya.
Now for CHCl3, shouldn't the dipole of carbon hydrogen be towards carbon?
They
Because
don't have
carbon is
much
more
difference
electron.
in their electronegativity. उनमें बहुत ज़्यादा difference होता नहीं है. Their electronegativities are very close. So we take this bond as almost non-polar. Okay.
Okay. Yes.
So let's do some questions. क्या? एक तो put dots. मेरे को दिख नहीं रहा है, ये scroll कैसे नीचे आ रहा है. अच्छा, okay, दिखा. The answer की H2S, HBr, NF3, HBr बीच में क्यों आया? बट HBr बीच में तो नहीं आना चाहिए. I'll see and I'll let you know. ठीक है? दिव्या, you can text me. तो अभी we were doing this aldehydes, ketones and carboxylic acid chapter, and I think I have not taken any booster session of this chapter. Yes, I have not taken any booster session of this chapter. So this is the first one, and we have done our like what all topics we have done. We did the nomenclature part. Then we studied about the preparation of aldehydes, ketones together, separately aldehydes, separately ketones. Then we discussed about physical properties, and then we started with the chemical properties, wherein we discussed about nucleophilic addition reaction. In a nucleophilic addition reaction, we studied the addition of HCN. We studied the HCN addition of किसका पढ़ा था HCN के बाद? Hydrogen cyanide, then Grignard reagent, then alcohol, और किसका पढ़ा है? Ammonia and its derivatives. So these topics we covered. So I added some questions over here. We'll be doing them in today's class. NaHSO3 as well. Yes. So, yep, here is the first question, which says that you have to write the structure of alpha methoxypropyne aldehyde. Is this a common name or IUPAC name? Tell me quickly. Common or IUPAC? Common name, right? So how will you draw its structure? Very simple. The first one, alpha methoxypropyne aldehyde, 1, 2, 3. At alpha position, you have methoxy group, so OCH3, CH3 here, CH here, and propyne aldehyde, that means CH2 here. At alpha position, this is your alpha position, at which you have methoxy group. Second one, you have 3-hydroxybutanol, which is very simple. 1, 2, 3, 4. At third position, you have hydroxy, and this is your aldehyde. So this is 3-hydroxybutanol. Right, beta? Then we have the third one, which is 2-hydroxycyclopentane carbaldehyde. So cyclopentane is this one, and carbaldehyde is CHO present on any cyclic ring, and at second position you have hydroxy. So it is 2-hydroxycyclopentane carbaldehyde. Right? After that, we have the next one, 4-oxopentanol. Pentanol is 1, 2, 3, 4, 5. At fourth position, you have oxo. And pentanol, this is C double bond OH, H3, sorry, not H here. And here H2, here H2. So this is the fourth one. Next we have is the fifth one, disecondary butyl ketone. So is this common name or IUPAC name? Disecondary butyl ketone. It is again common name. So you have 2 times secondary butyl and it is ketone. So secondary butyl is this one, CH3 here, CH3 here, H2. Secondary butyl, CH2, CH3 and CH3. अच्छा यहाँ पे एक और CH2. This is disecondary butyl ketone. Then sixth one we have is here is 4-fluoroacetophenone, and acetophenone is COCH3 present on your benzene ring. C double bond O CH3. So at fourth position you have 4-fluoroacetophenone. Clear? Is this clear? Okay, next one we have is, yep, you have to name the reagents to bring about the following transformations, wherein the first one you have is hexane 1-ol to hexanal. You have to convert alcohol to aldehyde. So which reagent you will use? Alcohol to aldehyde, guys. Isn't that isopropyl in previous slide? मैंने क्या बनाया है? डाई सेकेंडरी ब्यूटाइल. हाँ ये है आइसोब्यूटाइल. सेकेंडरी ब्यूटाइल होगा. हाँ 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 हाँ. Sorry guys, I made a mistake. This is isobutyl. If you want to write secondary butyl ना, so you should have this group. Sorry, I made a mistake. This is secondary butyl. Sorry. हाँ. Secondary butyl is this one. Understood? Yes, I made a mistake. गलती से मैंने इसको isobutyl बना दिया. Yes, guys, understood. So you have to, like, your structure here would be, oh, एक second. This is CH3, CH2, CH3. Secondary butyl 2 times you have, so it is CH2, CH3 and CH3. Yeah. Disecondary butyl ketone, right? Next one, hexane 1-ol to hexanal. Yeah, which reagent will you use? You can use PCC, you can use CrO3, you can use copper at 573 Kelvin. Yes. So PCC, CrO3, copper at 573 Kelvin. Second is cyclohexanol to cyclohexanone. Cyclohexanol, again alcohol to a ketone. So this is secondary. In case of secondary, what you can do? Again, you can use any of them, right? Alcohol to your ketone. Secondary alcohols, they always give ketone, right? So again, you can use any of them, same. Third one here we have is 4-fluorotoluene to parafluorobenzaldehyde. Can you tell me the name of this reaction? Itard reaction, very good. And what do we use in, which reagent do we use in Itard reaction? Which reagent do we use in Itard reaction? CrO2Cl2 chromyl chloride and carbon disulfide or CCl4. So yes, the reagent, this is Itard reaction. And you can use CrO2Cl2 chromyl chloride in carbon disulfide or CCl4. Next, ethane nitrile to ethanol. What is the name of this reaction where alkyl nitriles are converted into aldehydes? This is Stephan reduction. Stephan reduction. And here what do we use? We carry out the reduction with stannous chloride and HCl, followed by hydrolysis. Next, allyl alcohol to propanol. What is allyl alcohol? 1, 2. This is allyl alcohol. And you want to convert it into, इसमें convert करना है propanol. Again, you want to convert into propanol, CH2 double bond CH, CHO. Again, this is alcohol which you want to convert into aldehydes. So yes, you'll be carrying out its reduction with PCC, CrO3, copper at 573. You can use any. Next one, but 2 into ethanol. But 2 into ethanol. इसमें क्या करना है आपको? This is easy. What you will do here? Ozonolysis. Very good. If you have butene, 1, 2, 3, 4. This is butene and you want to convert this into ethanol, that is CH3CHO. So you will be carrying out its ozonolysis. Reaction with ozone followed by reaction with zinc and water. Right? Any problem till now? Any problem, guys, till now? Clear? Let's move ahead. Yes. Write the structures of products of the following reactions. This is a benzene and you are carrying out its reaction with C2H5COCl. What is the name of this reaction? What is the name of this reaction? This is Friedel-Crafts acylation. And here hydrogen from here and Cl from here. So what you will get is C6H5 CO, अच्छा sorry, ये तो C2H5 है. Sorry guys, it is C2H5. Next we have is C6H5CH2. This dialkyl cadmium, dibenzyl cadmium, and you are carrying out this reaction with CH3COCl. This is the second, this was I think first method of preparation of ketones. So what you will get here, that CdCl2 will remove and you will get CdCl2 will remove and what you will get here is C6H5 CH2 C double bond to CH3 along with the removal of cadmium dichloride, that is CdCl2. Clear everybody? Ma'am, can you write the name? Yes, we can write its name as well. This is a chain and you have to select this chain. Then you will be doing numbering. Of course, you will be doing numbering from this side. 1, 2, 3. This is 1-phenyl propanone. 1-phenyl propanone. Right? Okay, next. Third one, this is propalkyl and you are carrying out its reaction with mercurous ion and sulfuric acid. So what we will do here? What we will do here? Hydration, very good. Can you slow down? I'm noting down. Okay. Sorry. Sorry. You can note it down and once done, you can let me know. I thought you are done. So sorry guys, in case you're feeling like that. So you can note down and you can let me know. Done. Okay, let's move ahead. So here we'll be carrying out hydration, right? This is acid catalyzed hydration of alkynes, and if you will be carrying out the addition of water, we'll be carrying out the addition of water. Now this is your positive and this is the negative. This has one carbon, this has 0. So negative part will go to the carbon which has less number of hydrogen atoms. So what you'll get here is CH3, COH, double bond CH2, right? Now here this is enol form, this will undergo tautomerism. This is enol and will undergo tautomerism. So here this hydrogen is acidic, this would acquire negative, this will be having positive, so pi electrons will shift here. So what you'll get here is CH3, C double bond O and CH3. So from propine you are getting propanol. Next, what is the name of this reaction, guys? Carrying out its reaction with CrO2Cl2. Ma'am, how did we get water? But in this reaction, we carry out the reaction with dilute H2SO4. So there water is there, and yes, you will be getting the reagents like this only. They will not show water. Okay. You have studied this reaction. Yeah. So this is a retard reaction again. So where CH3 group will convert to CHO group, NO2 will remain as it is. CHO, NO2 will remain as it is. Right? Next. Done, Shahini. Okay, let's move ahead. Next question here we have is, would you expect benzaldehyde to be more reactive or less reactive in nucleophilic addition reactions than propanol? Explain your answer. What do you expect benzaldehyde, which is C6H5CHO, C double bond O, H, to be less reactive or more reactive in nucleophilic addition reaction than propanol? And propanol is CH3, CH2, CHO. Right? Less reactive, less because more steric effect and more inductive effect. Here in case of this one, benzaldehyde, beta nucleophile goes to that carbon, the carbon which is more electrophilic, right? Here pi electrons will shift towards this oxygen. So this carbon would acquire positive charge. If this carbon would acquire positive charge, of course, if this will be having positive charge, then pi electrons will shift here. There will be resonance effect, like it is getting the electrons from the benzene ring by resonance effect. So yes, I can show you its resonance structure. This is your benzene ring. C, this oxygen is having negative charge, positive here, negative here will make a bond, and this is your hydrogen. So you can draw other resonance structures as well. So you can see that electrophilicity of the carbon is getting reduced over here. That is one reason. Second one is the steric hindrance. Steric hindrance here is more. Now if I'll talk about this one, in case of this one, your pi electrons will shift towards oxygen. If pi electrons will shift towards oxygen, so CH3, CH2, single bond C, O negative, and this is your hydrogen. Now this carbon has positive charge, but that there is one alkyl group which will be donating electrons to this carbon, and if it will be donating electrons to this carbon, there will be increased electron density on this carbon, but not as much as in this case because of resonance effect dominates. Resonance is more effective as compared to inductive, and also your hindrance is less. So yes, this benzaldehyde will be less reactive, and this will be more reactive in nucleophilic addition reaction. More reactive. Is this clear? Everybody? Is it noted? All right, let's move ahead and let's move towards another question. Arrange the following compounds in increasing order of the reactivity in nucleophilic addition reaction. We have ethanol, propanol, propanone, butanone. What do you think out of all of them, which one would be most reactive? Ethanol is in the first part CH3CHO. You have propanol, which is CH3CH2CHO. You have propanone, which is CH3 C double bond O CH3. And you have butanone, which is CH3 CH2 C double bond O CH3. Most reactive, ethanol. This is most reactive and this is least reactive. Next one, second one we have is benzaldehyde, para-toluene, para-nitrobenzaldehyde, acetophenone. Benzaldehyde is C6H5CHO. Para-toluene is at para position. This is your benzaldehyde. And at para position, you have your toluene, matlab CH3 attached. Para-nitrobenzaldehyde is NO2. Then we have acetophenone, which is CH3, C double bond O, C6H5. Most reactive. Shouldn't propanol and propanone be same most now? No. If I'll talk about propanol and propanone, here you can see there is hindrance from one side only, but here there is hindrance from both the sides. Hindrance here is more as compared to this one. Okay.
Ma'am, but in propanol, the hindrance is from a bigger alkyl group, right, compared to.
So nucleophile will attack from one side only, na? अब वो दोनों तरफ से तो नहीं अटैक करेगा, it will attack from one side only, and from this side hindrance is not there, so it can easily attack as compared to this one. Okay. So here which one will be most reactive पूछा ना? हाँ. So let's mark this as 1, this as 2, this as 3rd, this as 4th. Yes. Tell me which one will be most reactive here. Third one is most reactive as it has nitro group which is at para position and it is electron withdrawing. So more electrons it will withdraw, more will be the electrophilicity of this carbon. Here it is electron donating, so it will increase electron on this carbon. So yes, this will be third, will be most reactive. Then you have the next one which is first one. Then you have fourth one and least is of second one. Clear? Done. Okay, let's move ahead. Predict the products of the following reactions. First, what is the name of the first reagent? NH2OH is called. It is ammonia derivative. And what is the name of this one? It is hydroxylamine. And whenever you are carrying out the reaction of aldehydes, ketones with ammonia or its derivative, I'm going to explain why fourth is greater than in the previous question. Then second, in fourth, you have CH3 group attached, na? Which will अच्छा मैंने कुछ गड़बड़ कर दी क्या? Sorry guys, यहाँ पे ना फोर्थ और सेकंड ओके ओके फोर्थ नहीं आएगा, सेकंड पहले आएगा आपका। ये गलत करा है मैंने, आई हैव मेड अ मिस्टेक हियर। Okay, let's look again. Here most reactive is this one, third one. ठीक है? And then you have this one, first one. Now we have to do the comparison in this one, fourth one, and in the second one. So second one will be more reactive, as with this carbon CO group, CH3 is not attached directly, rather it is attached at the para position. So here this second will be more reactive than the fourth one. Okay? Yes, you are right. Understood, guys? My mistake. Is this clear, all of you? Let's move ahead.
Ma'am, ma'am, but in the second one, we have one side where only hydrogen is attached, right? So that is the least hindrance compared to in the fourth one.
क्या मतलब? समझी नहीं मैं. What? You are making a comparison between
second and fourth.
Second and fourth. Okay.
So ma'am, in the second one, we have hydrogen attached to one side of carbon, so that is least hindrance, right? But the fourth one, we have CH3 and benzene, so both are producing steric hindrance.
हाँ, that is why it is less reactive, least reactive.
Okay, ma'am.
ठीक है. Next. So this is your hydroxylamine, and whenever we are carrying out the reaction with ammonia or derivative of ammonia, rapid dehydration takes place. So you just have to remove water, H2 from here, oxygen from here. Water will remove and nitrogen will attach with this one. So this is your cyclopentane, double bond N, single bond OH. And cyclopentane oxime is forming. This is oxime which is forming. ठीक है? NH भी नहीं ठीक है. Next we have is, what is the name of this compound? This is 2,4-DNP, right? 2,4-dinitrophenylhydrazine. And again here also rapid dehydration will take place. So H2 from here and oxygen from your water will remove, and this is your cyclohexane, double bond N, single bond NH, single bond C6H5, NO2 at second and fourth position. Right? Next one. This is your aldehyde, and you are carrying out its reaction with NH2CO, NH2. This is called semi-carbazide, but we have not done this. But because the question is here, let's do it. It is again ammonia derivative. आपको मैंने बताया था ना about this NH2, like in place of hydrogen you have CO, NH, NH2. This is called semi-carbazide. Please keep in mind that whenever you are carrying out the reaction with semi-carbazide, you have NH2, NH, C double bond O, NH2. You are carrying out its reaction with, किसके साथ करा रहे हो? RCH double bond CH, single bond CH2. RCH double bond CH, single bond CHO. This is again ammonia derivative, wherein in place of hydrogen you have this Z. This is your Z. So please keep in mind, again rapid dehydration will take place over here, but please keep in mind that H2 from here and oxygen from here, your water will remove. H2O will remove, and what you'll get here is RCH double bond CH, single bond CH. This is double bond. This will link with double bond. H2 you have removed from here, so double bond N, single bond NH, CO NH2. You have to remove H2 from here, not from here. I'll give you the reason as well. First of all, tell me if it is clear the product I have written. This is semi-carbazide. Semi-carbazide. And here semi-carbazone is forming. Semi-carbazone is forming. Is this clear, guys? Is this clear to everybody? So let me give you the reason like why we are not removing H2 from here. Because you very well know that whenever we carried out the reaction of this ammonia or its derivative with aldehyde or ketone, like you are carrying out its reaction with NH2, NH, C double bond O, NH2. This nitrogen has lone pair. This nitrogen also has lone pair. But the lone pair which is present on this nitrogen is involved in resonance, no? This, let me draw it on another slide. NH2, NH, C double bond O, NH2. Nitrogen has lone pair. This nitrogen also has lone pair. So, the lone pair here is involved in resonance. Electrons will shift here. Oxygen will have negative charge. This carbon positive. So yes, do you think that this nitrogen is free for attack, like for donation of electron? The one which is linked with CO. Tell me, guys. O negative, double bond N, H2 positive. Yes, beta. Tell me. Do you think that this nitrogen which is having lone pair, there are two nitrogens which are having lone pair, and those who can donate the electron pair. Lone pair present on this nitrogen also is involved in resonance. So you will be removing H2 from this side. First of all, tell me if this is clear, this part is clear, then I'll come back to the mechanism. Everybody, attack onto the electrophilic carbon will take place through this nitrogen, not from this nitrogen, as the lone pair is involved in the resonance. Yes, guys. Is this clear? So coming back to this one, penny गिर गया नीचे, wait. Coming back to this one. So your attack, like the pi electrons, they will shift here. So your attack will take place through this nitrogen only, not through this nitrogen, as the lone pair is not free. So in its mechanism, RCH, this O is having negative charge. With this carbon, your nitrogen will attach. So NH2, nitrogen has donated its electron pair, will get positive charge. Single bond NH, CO, NH2. Now, nitrogen can't tolerate this positive charge, so proton will leave from here. Proton will leave from here, so pi electron, the bond will get cleaved in such a fashion that the electron will shift towards nitrogen. And what you will get? RCH. H plus will leave and that will attach there. OH, NH, NHCO, NH2. Right? Now again with the same, with the nitrogen atom, with this carbon atom, two electronegative elements are linked, oxygen and nitrogen. So here rapid dehydration will take place. So OH from here and H from here, your water will remove and you'll get the above product. That is RCH double bond N, single bond NH, CO NH2. So whenever you are carrying out the reaction with semi-carbazide, you have to remove H2 from this nitrogen which is not directly linked with CO. Is this crystal clear to everybody present in the class? All the students present in the class, is this crystal clear? Can you explain the direct reaction? Yes. In the direct reaction, you just have to, this is ammonia derivative, so you have to remove water. So H2 from here and oxygen from here, your water will remove. With this carbon, double bond N will link. So HCH double bond CH till here, it is this one. With this carbon double bond N, single bond NH, CO, NH2. Is this clear, Mahi? Next one, guys. I think the bottom part is visible. The question at the bottom is visible to you. Okay, so what will happen here? This is again alkyl amine. Alkyl group is there and NH2 is there. So yes, there will be removal of water. H2 from here and oxygen from here. So what you will get here is C6H5. CH3, double bond N, single bond CH2, CH3. Is this crystal clear, guys? Okay, let's move ahead. You have this question which says, draw structures of the following derivative 2,4-dinitrophenyl hydrazone of benzaldehyde. So you have to draw the structure of 2,4-dinitrophenyl hydrazone of benzaldehyde. So how you will draw it? The first part, benzaldehyde is C6H5CHO. C double bond OH. This is C6H5CHO. You'll get 2,4-dinitrophenyl hydrazone when you'll carry out this reaction with 2,4-dinitrophenyl hydrazine. That is NH2, NH, C6H5. This is 2,4-dinitrophenyl hydrazine. Again, it is ammonia derivative, so H2O will remove. H2 from here and oxygen from here. H2O will remove. And what you will get here is C6H5, CH, double bond N, single bond NH, and O2 here. This is the structure of 2,4-dinitrophenyl hydrazone of benzaldehyde. Is this clear, beta? Is this clear to everybody? Next, second we have is cyclopropane oxime. Oxime forms when you carry out the reaction with hydroxylamine, that is NH2H. So in the second part, you have cyclopropanone. Cyclopropanone is this one. Double bond O. And you have to carry out its reaction with hydroxylamine, which is NH2OH. So what you will get here is H2O will remove, minus H2O, and you will get double bond NOH. This is cyclopropanone oxime. Cyclopropanone oxime. Okay? Clear, everybody? All right. Next, we have the fourth one, semicarbazone of cyclobutanone. Semicarbazone you will get when you will carry out the reaction with semicarbazide. So, of cyclobutanone, and cyclobutanone is NH, semicarbazide is NH2, NH, C double bond O, NH2. So H2O will remove, H2 from here, oxygen from here. Double bond N, single bond NH, CO, NH2. Right? Third one. Acha, third one reh gaya. Sorry. Sorry, I missed that. This was fourth one. Third one is acetaldehyde dimethyl acetal. I think I explained you this reaction, na? Acetal 1. Acetal ho gaya na? Hemiacetal, acetal. Alcohol wala. Yes. With alcohol. So let's do the third part. Acetaldehyde dimethyl acetal. Okay. This was fourth. Acetaldehyde dimethyl acetal. See, this acetal we get when we carry out the reaction of aldehyde with alcohol. And here in the question they are saying that you have to get acetaldehyde dimethyl acetal. That means you have to take aldehyde as acetaldehyde, which is CH3CHO. And you want to get dimethyl acetal, that means you have to take R group here as methyl LOH. The reaction is carried out in the presence of dry HCl. Dry HCl. And pi electron, like this hydrogen is acidic. So this is positive, this negative. This will come and attack here. So what you'll get here is CH3, CH. मैं इसको ऐसे बनाती हूँ. Wait. CH3, CH here, O H here, and this is OCH3. This is hemiacetal. And you'll carry out its reaction with another, like this further reacts with another molecule of alcohol, and you'll get OH from here, H from here, water will remove, and OCH3 will attach, and you'll get acetal, which is geminal dialkoxy. OCH3 here, OCH3 here. This is acetal. Clear? Any problem? Once done, you can let me know in the chat box. Noted, guys. Okay, let's move ahead towards the next one. Third and fourth are done. Next, we have is the ethylene ketal of hexane 3-on. That means we have to carry out the reaction of hexane 3-on with ethylene glycol, and you'll get ketal. So fifth one is hexane 3-on. 1, 2, 3, 4, 5. This is hexane 3-on, and you are carrying out this reaction with the ethylene glycol, CH2OH. So there will be removal of water. H2O will remove. And what you'll get here is CH3, CH2, C. इसको थोड़ा नीचे करके बनाते हैं. CH2, CH3, OCH2, OCH2. This is ethylene, hexane 3-on ethylene ketal. Right? Next one. Next one is methyl hemiacetal of formaldehyde. That means you don't have to make here acetal. You have to make here hemiacetal. That means you just have to carry out the reaction of this formaldehyde with methyl alcohol. Just one time reaction. So formaldehyde is HCHO. Sixth one here is formaldehyde, which is HCHO. And you are carrying out its reaction with methyl alcohol, that is CH3OH, in the presence of dry HCl. This bond is polar, positive, negative. This will come and attack here. You will get hemiacetal, that is CH3, CH2, OCH3. This is hemiacetal. Clear, guys? Any problem? अरे यार मैं क्या कर रही हूँ आज? हेक्सेन, अच्छा, ओके, इट वाज हेक्सेन 3-on ना, तो इसको यहाँ पे यू कैन टेक इट एज CH3 CH2. हेक्सेन 3-on है, 2-on है, 3-on है ना? हाँ तो 1 2 3 ठीक है, 1 2 3 4 5 6 हेक्सेन 3-on. So this is cool. Now it's fine. Done. Okay. So, yeah. What is the next one? We have not done this part. Clemenson reduction. Excess ethanol and acid. Cyclohexane carbaldehyde. This we have done, like this is, can you tell me the name of this reaction? Carrying out the reaction of cyclohexane carbaldehyde. Let's do the fourth part. Cyclohexane carbaldehyde is CHO. Cyclohexane carbaldehyde reacts with excess of ethanol. That means you'll be carrying out its reaction with CH3, CH2OH, try HCl, positive, negative, will go here. So we'll get CHOH, इसको थोड़ा सा लिंक करके दिखाते हैं. OCH2CH3, and then it will again undergo reaction with the CH3CH2OH. So what you will get here is removal of water, OH from here, H from here, water will remove. Clear, beta, all of you? Is this clear? Ma'am, names will be hemiacetal and acetal regardless of number of carbon atoms. Yeah, just the name of that form. Okay. Semicarbazide and weak acid. Again, the third one you can write cyclohexane carbaldehyde, है ना? हाँ. C double bond OH. carrying out its reaction with NH2NH CONH2. So there will be removal of water, H2O. Right? Already 5 minutes left. 3 minutes left. Hanji. This is done, and tolerance reagent, we have not done this. We have done this reaction. Reaction with Grignard reagent. So let's do this part as well. First one. This is pH MgBr. This is positive, this is negative. This will come and attack here. What you'll get here is benzene ring, OMgBr followed by hydrolysis in acidic medium. So MgOH Br will remove, and hydrogen will attach here. Is this clear, guys? Is this clear till now? Everybody? 100 cc. So we are done with this part as well. This will be doing, like tolerance reagent, we have not done this. Second and the fifth part. That we'll be doing after we'll finish this topic. Okay? So let's leave it here for today. Remaining part we have not done, so we'll be doing them in the next booster class once we'll be done with those topics. Okay? Chalo. So thank you so much, guys. Enjoy your day. Happy Raksha Bandhan to all of you once again. See you in the next class. Bye, guys. Bye, everybody. Bye bye. Bye, all of you. मजा आ गया मेरे को भी आया. Thank you. Bye bye. Good night. Take care. Bye, all of you.